Welcome everybody to this lecture where I would like to talk about the principal-agent conflict. The structure is as follows: that in the basic scenario we will solve the problem of the principal in case that there is no agent at all, so we learn about the underlying problem of the principal. Afterwards we will talk about the principal and agent in conflict, and in the end we will compare the two scenarios. What is the initial scenario? The basic scenario looks as follows. There is one principal and this person owns a company. The principal, this person, has to work in this company in order to generate an output. The problem is that when a person is working, this comes with a disutility of effort. Labor input is associated with cost. Therefore, we have the following research questions. How many hours should the principal work? And what are the characteristics in the equilibrium? The return depends on the effort level and the marginal productivity. The output level, R, the revenues, is influenced by the effort level E and the marginal productivity rho. In our numerical assignment, we assume that the marginal productivity is constant, so rho is equal to 10, and this implies that in 1 hour the principal is able to create 10 units of output. The return is equal to rho times E, like the marginal productivity times the number of working hours the principal is spending in his company. When we visualize these assumptions here, then it is the case that we have here on the horizontal axis, we have the effort level, the working time in hours, and on the vertical axis we have the revenue, the quantity of products produced by the person. In case that the person spends 5 hours in the factory, the output will be equal to 50 units of output, and in case that this person is spending 10 hours in the factory, the revenues will be equal to 100 products. So we talked about the revenue side already. Let's also talk about the cost side, and cost depends on the effort level. Labor input causes cost in the form of the opportunity cost or disutility of effort. The cost function is given here. C is equal to 1/2 effort squared. When we differentiate the costs with respect to the effort level once, we get that marginal costs are positive, equal to E. And when we differentiate it a second time with respect to E, we learn here that the second derivative is positive. Due to the fact that the second derivative is positive, the marginal costs are not constant, but marginal costs are increasing because of the fact that the second derivative is positive. The more one has already worked, the more distress arises for each additional hour of work. For example, when you serve as a waiter in a restaurant and you have worked already 5 hours, so it's to some extent hard to work the 6 hours. But when it comes to the 7th or 8 hours, it's always getting harder, like the cost for working 1 additional hour becomes higher and higher and higher because it's much tougher to provide this effort level. This is the assumption behind this equation number 2, where the second derivative of the cost function with respect to the effort level is positive. Frequently we look for an intersection in order to find the profit maximum, but here we have to be careful to some extent because we talk about revenues and cost. So when we pick, for example, to work 20 hours, this would not maximize the profit because the revenues would be equal to 200 and the costs would be equal to 200, so that the profit would be equal to 0. So it makes sense to work in this area here because of the fact that in this area revenues are larger than cost, so that the profit is positive. But what kind of working time maximizes the profit? In order to answer this question, it makes sense to differentiate the revenue function and the cost function 1 and create a diagram where we insert a marginal revenue curve and a marginal cost curve. This is performed in the next diagram. The black line indicates marginal revenues and the red line indicates marginal cost. Marginal revenues are equal to 10 and they are constant. This is given by the parameter rho, which indicates that in 1 hour a person is able to create 10 units of output, and in the second hour it's also 10 units of output, and so on and so on. Marginal costs are given by this expression from slide number 5. dE is equal to E. So it is a 45 degrees line, slope equal to 1, and this is given by the equation number 2. We have to look for the intersection of the marginal revenue curve and the marginal cost curve. So the optimal working time in hours is equal to 10 hours. Until now, we have solved this problem in a graphical way. Of course, we can also solve this problem in a more formal way. Let's do that. Profit is defined by revenues minus cost. So profit pi is equal to R minus C. Let's plug in the information we have. Revenues are given by rho times E, and then we have to subtract the cost 1/2 E squared. The necessary condition, we have to compute the first derivative, and we have to set the first derivative equal to 0. What is under control of the principal? Under control of the principal is the amount of hours spent in the factory. This is a variable which is under control of the principal, so the profit function has to be differentiated with respect to E. Hence, we get d pi dE is equal to rho. This rho stems from the revenue function, represents marginal revenues, and then we get here E minus E. This represents marginal cost, and this has to be equal to 0. The necessary condition indicates that E has to be equal to rho. Hence, the person should spend 10 hours in the factory because of the fact that rho is equal to 10. The sufficient condition for a maximum, we have to compute the second derivative, and we have to check whether the second derivative is negative. When we differentiate equation 4 once more with respect to E, we get a -1 here. This is smaller than 0, and therefore we can be sure that this is a maximum and not a minimum. Let's compute the size of profits in the maximum. Size of profits is given by revenues, which is given by 10 times 10. Revenues are equal to 100. The costs are equal to 0.5 times 10 squared. 10 squared, this is 100 times 0.5. The costs are equal to 50, and hence the profit is equal to 50. This is larger than 0, and therefore it is the case that the principal will work 10 hours in the factory and the principal will receive a profit of 50. On the previous slide, we saw that the profit is positive. This is very important for the so-called participation condition. In case that the profit would be negative, the principal would close down his company. Here the profit is larger or equal to 0, so the principal will start working. This condition here is called participation condition. In our numerical example, the participation condition is fulfilled. Participation condition implies the person will participate, the person goes along with it, the person shows up at work. So in this part of the lecture, we rolled out the underlying problem in case that only one person who owns the factory has to work in the factory, and we were able to derive the optimal hours of labor spent in the factory. In the next step, in the next video, we'll show what happens if the principal is hiring an agent who should work, and the agent should work in the factory. A so-called principal-agent conflict will break up, and we will solve the principal-agent conflict in the next step. Thank you very much for watching this video. Take a short break, review this first basic scenario, and watch the next video in a few minutes. Thank you. Bye-bye.